So in my previous video I have talked about stereoisomers, optical activity, reference sugar. So now it's time for epimers. Now what are epimers? For example, I am having a compound one, two, three, four, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So all valencies are complete, right? This is carbon number 1, carbon 2, carbon 3, and carbon 4. So in epimers, we basically focus on OH group. We will locate OH group, like where it is present. For example, I am making another compound which is so this is carbon number 1, carbon 2, carbon number 3, and carbon number 4. So what's the basic difference between these both compounds? Like in carbon number 3, in this side, in right side it is hydrogen, but here it is OH. So basically the OH group is shifted. In this, the right side is H and the right side is OH. In this left side is H and in this left side is OH. So basically what is happened, like OH has changed its position. Now these both are known as epimers. Why they are known as epimers? Because the both compounds are same, but there is a difference in the position of OH. That's why they both are known as epimers. Now let's talk about enantiomers. What are enantiomers? Enantiomers are known as mirror images. For example, I'm drawing a compound it's quite simple compound and I have placed a mirror over here. Now the hydrogen was here, now it will come in this side. Now as you can see the basic difference between these both are mirror images. These both are non-superimposable images, which means the compounds when placed on one another do not place on same position. For example, when you place this compound over this compound, you won't get the same position. Obviously not, because in this hydrogen is in this side, but in this compound the hydrogen is in right side. So obviously these are non-superimposable images, which means that compounds when placed on one another do not place on same position, and they both are mirror images. So there can be only two enantiomers of one compound. So in nature there isn't a mirror present, but still they both have mirror images. So these compounds are known as enantiomers. Mirror images are known as enantiomers. So now let's talk about diastereomers. So they are non-mirror images are known as diastereomers. For example, I'm drawing compound this line is just to show the partition. So as you can see over here, what's the basic difference between these both compounds? Like these are not mirror images. If they will be mirror images, how the hydrogen can be placed on the same side? Obviously they are not mirror images. You can see on carbon number 2, the hydrogen is placed over here and OH is placed on the left side. Here OH is on right side and hydrogen is on left side. So there is a change in groups, like there is a change in position. These are known as diastereomer. Now you will say that then what's the difference between epimer and diastereomers? So in epimers we are restricted to only OH. Basically in diastereomer there can be another group of atoms, there can be another molecule, but in epimer we are only restricted to OH in epimers. But in diastereomers there can be any compound, that can be any group of atoms, that can be any molecule. So basically epimers are diastereomers. Epimers are diastereomers. So in diastereomers there can be any other group of atoms, but in epimer we will just focus on OH.